Hello, 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 hello. Grade 11s, please, in the comment section, comment heavily if you're in grade 11. Just let me know. Yo, 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 jo, jo, jo. KTV, ew. BTK4. Yeah, Dumelang. Absheni, hello. Okay, guys, so this is grade 11 goodness. Def not kaboom. This is grade 11 indeed. Grade 11 headache, this one. Grade 11 headache. I wonder why would you call this a grade 11 headache? Okay. BTK4. You want me to make this a YouTube video? Yes, I will upload this as a YouTube video. But let me tell you this. BTK, are you in grade 10? I mean, are you in grade 11? And when are you writing BTK4? Because I saw you said you're going to sleep now. You're going to bed. Or you're in grade 12. You're writing Friday. So you're okay. Hello, Dad, Doc. Is it Doc? Doc? Doctor? Hello, Doc Skinned. Ojaing the minier. Yo, I need resuscitation right now. So I'm just having some snacks, like midnight snacks, eh? Midnight snacks, hola. Okay, let's take it one problem at a time. Remember, we've been doing a lot of these anyways as grade 11, so this is no different from what we've been doing. We're just wanting to revise and get, familiarity happening. I was hoping dark-skinned Han would help me out with answering these problems one by one. So if she can kindly unmute, that would be great. Def not kaboom, grade 10. Tomorrow, my dear. When are you writing? Answer me that question. But when I say tomorrow, it's not going to be on this platform. I have a grade 10 platform. It will be there. So you're writing Friday. What paper are you writing? Paper 1 or paper 2? Def not kaboom. I was not ignoring you. Dark skin. Are we answering this? Paper 1.
Yes.
Yeah. So dark skinned, what grade and when are you writing?
I'm in grade 11. Upala
Yes.
Friday.
Yes. Ooh, you're in grade 11. So what time are we sleeping, dark skinned? So that I can take my orders, my marching orders from you.
Yo. To 1.
We are slipping to 1. Okay, let's go. Yeah. Yeah. I love your yo. That one, I think it deserves. No, wrong one. What happened there? Hey, this game. Yeah. Why did it choose that one? I mean, come on. I wasn't trying to laugh. Okay, let's go, Duck.
Oh, sizokhipha a-common factor ekuyi-9.
Sayikhipha i-common factor engu-9.
9 into
Mm.
x squared
Mm-hmm.
minus 9
Mm-hmm.
equal to 0.
Mm-hmm.
Then divide both sides by 9.
Mm-hmm. What gets left behind after we do that?
X squared minus 9 is equal to 0. Then we equate to negative 9. So positive 9, then we square both sides. X is equal to plus minus 3.
So your plus minus, where does it start featuring? Where do you actually introduce it? At what point?
From the square root 9.
Okay, so I introduce it here.
Mm.
Okay, thank you. So the answer is?
Plus minus 3.
All right. Are we done?
Yeah.
Okay. No, I'm just checking. Okay. So, 1 mark. Kadi standard form. 2 marks. Kadi 2 answers. Okay. Next. Let us just... Beautiful work from our dear dark-skinned. Yeah. This one. 1.1.2.
Foil method. Then slope equate to x. So about 6x squared minus 15 is equal to x.
Yes.
6x squared minus x minus 15 is equal to 0.
Hey. Thank you so much, Sekhamete, for your awesomeness.
Then quadratic.
Okay, you want to venture into quadratic? Okay, so
x is equal to negative b plus minus square root of b squared minus 4ac over 2a.
Yeah.
X is equal to negative into negative 1 plus minus root of negative into negative 1 squared minus 4 into 6 into negative 15 over 2 into 6.
Okay.
Calculator ishilekile.
Tini, what? Calculator?
Ish.
60. Ah, man, come on. I thought the calculator is always here with you all the time. All the time. Bianong. All right, so that is 1 plus 320, which is 321. all over 12. I honestly love revealing this step, okay? Because I found that sometimes some examiners, what they do is they allocate a mark for one value, one value, one value. So in as much as I know most people, they just substitute calculator, voila, answer. Okay.
Yes.
I think there was one paper that I saw where the examiner allocated a mark. Obviously, I don't think they will penalize you just because you did not show this step, but I just thought to myself, never again. Did I make a mistake there? Oh, it's 361. My bad. My mistake, my fault. Thank you so much there in the comment section. We've got beautiful people in the comment section that are watching out. Didintle onkarabile. Onkarabile. Thank you so much. Okay. So then, 361, square root of 361 gives us 19. So that means this thing was factorizable. But it's fine. It's not a train smash, right? X is equal to negative 18 over 12. And x is equal to 20 over 12. So if you simplify that, dark skin. Did you say negative?
Negative 3 over 2 because so divide by 6.
Okay, negative 3 over 2 or? I think Queen Bee has helped you out there in the comment section. Ne? Is that fine, dark skin?
Yes.
All right. Okay. So yeah, advanced trinomial, that one, 6x squared minus 6x minus 15. You could have applied any sort of like, because remember in grade 10 you learned how to factorize equations where the coefficient of the x squared term was not 1. So it was possible to factorize. But no problem, no train smash. We got the marks there. Let's just allocate some marks. So our standard form, no doubt, substitution, no doubt. Then if it's 4 marks, let's say the answers, the solutions. Okay. So standard form, substitution into the quadratic formula, correct substitution into the quadratic formula, our 2 values. All right. Okay. Next. Array dark skin.
Oh. So expand le brackets like x squared plus x. So expand.
So you're gonna expand this. Are you sure you want to do that? So let's just observe, ne?
Oh, K method.
Dark skin. So can I ask you a fundamental question, dark skin? Why is it that you did not see it from the beginning?
Ish. Ngazi, ish.
Yeah. No, it's fine. I'm happy that we had the moment where we're like, "Sizo expand," because what you would have obviously seen when you expand is that x to the power 4, which will give you red flags immediately. But hey, you can't move with this one.
Today, like, ngiyenzile something of this nature.
Yeah, when okay.
Yeah, le.
Okay.
Yafana.
Yafana, ne?
Yes.
Okay, then if you did something similar, then hey, I guess I see why you had confidence to just request and come up and do these things. You were like, ngamanzi amancane la. You were like, into encane le.
Okay, so
Okay. Let
x to the power 2 equal to k.
so you are letting x to the power 2 be equal to k.
Yes.
Okay, so once again, I'm going to say, look again. Are you sure about letting x squared be equal to k? What is the concept here? Repeated expressions, eh? X squared plus x, x squared plus x.
Plus
So the concept,
x.
yeah, okay. So yeah, let's add, I guess you could say the meat to everything that you did, with that other problem. So the thing was in grade 11 is that with any repeated expressions in an equation where one you could potentially get x to the power 4, you can see that there's the hazard of getting x to the power 4. We try and deviate from that, and we use the k method, because k becomes the way to x. K is just an intermediate way that we take. I usually call it the K-way. K-way Moss is the brand. Everybody loves K-way. K is the way to X. You see? Eh? Yeah. All right, let's continue. X squared. Let x squared plus
X equal to
yeah equal to k. The entire expression, it's repeated. So for the first term, we have x squared plus x. For the second term, the 4 coefficient precedes the x squared plus x. So we take that repeated expression, we let that be k. Okay.
Okay.
So
K squared.
Thank you. Yes, k
Plus
squared.
4 plus 4k.
Yeah.
Minus 12
Minus 12.
is equal to 0.
Yeah, now I'm trying to wonder here, dark skinned, what were you going to do had you substituted x squared alone? K plus x, the whole thing squared, plus k plus x minus 12 is equal to 0. Two variables in one equation. Then it's going to be like, hey, and then what do we do? Two variables.
Sorry.
No, it's no problem. Don't apologize. I'm just, we are just revealing the obvious. Because remember, when you are here, ne, in as much as you're making your own errors, there are people who would probably make the same error. So those who are listening, they listen with, eager eyes, because they also want to have clarity for themselves. So it's okay. Don't apologize. We are in progress, so it's fine.
Open two
Okay.
sets of brackets.
Yeah.
K and K
KK.
plus minus
Okay, plus minus, yeah.
plus 6 minus 2
Plus 6 minus 2. Good job.
is equal to 0.
Epic.
Then k is equal to negative 6, or k is equal to 2.
K is equal to negative 6, or k is equal to 2. Indeed.
Yes.
Those are our k values.
So k is x squared plus x. X squared plus x is equal to -6.
Okay, there we go. Finally found one of the culprits. -6 must come here. Okay.
X squared plus x is equal to 2.
The second culprit.
Then x squared plus x plus 6 is equal to 0.
Okay, nice.
Open two sets of brackets.
Okay.
X and x.
Are we sure? Are we sure?
Or
Yeah.
quadratic.
Quadratic. Is the quadratic even gonna work here?
Yes.
Squared minus 4ac. B is 1. 1 squared minus 4 times 1 times 6. That's 1 minus 24. Inside the root, you are going to have a negative number. What does that mean about the solutions?
No solution.
Exactly. All right. So this is a situation where this cannot be factorized. 1, 2, there are no factors. 2, if you substitute into the quadratic formula, okay, I mean, that's fine. You can do that. Yeah, so that when you can see that, and I think it's fine. Let's do it so that even our friends at home can appreciate -1 plus minus inside the square root 1 minus 24, which is -23 over 2. So it's obviously no solution. Upper we have no solution. X has no. So for this equation, there's no solution, which is okay. It happens. Okay, it happens. And I think it's important that learners understand it happens. So your calculator will say maths error because it's non-real. No solutions, in other words. Okay. So we go over to this side.
X squared plus x minus 2 is equal to 0.
Is equal to 0. Yeah.
Open two sets of brackets. Equal to 0.
Yes.
X and x. Plus and minus.
Plus and minus, yes.
Plus 2 minus 1.
Definitely 2 minus 1. Indeed.
Then x is equal to -2 or x is equal to 1.
Awesome. That one, it satisfies the thirst. It quenches the thirst, that one. Yeah. So I think the warning there also then for not every equation is you can factorize, because you see, I think I'm telling you, I am under the belief that grade 9s and 10s don't realize how important it is to understand the method of factorization. You see, you saw in the comment section, dark skin, did you see some of the comments that were being said? People were saying, no sir, choose -3 and 2. And you are, and obviously, a +3 and -2, okay? Now the thing is, that +3 and -2, when you multiply it, you are not going to get +6. So I think the honest truth is that grade 11s and 12s don't really internalize this concept of when you have a constant term in your quadratic equation that is positive, the instruction is that you ought to have same signs in the bracket, ne?
Yes.
Yeah, that is the rule. Positive means same signs where inside the bracket.
Okay.
But this positive here says that those signs inside the bracket should be positive, but only on condition that the factors of 6 do exist that you can multiply, which will give you 6, and then when you add them, will give you the coefficient of the middle term. That is the condition. So now, if you are going to have people saying plus and minus, it means from the foundation of factorization, people don't really comprehend the method that we apply when factorizing quadratic trinomials. And that's why some people will carelessly write that 3 and 2 and will write it as positive and negative. And it's so wrong. But then the thing is, people do it because they are not aware that if the constant is positive, that means same signs. If the constant is negative, that means different signs. You've been doing that quite well, I must say, because I've been seeing you every time. It's like you say every time we are at a trinomial stage, you always start with the letter, right? And then you follow it up with the sign, right?
Yes.
And it's informed. Your sign being written inside the bracket is informed by the constant term and further influenced by the middle term as to which factor is going to get the positive sign if it is different signs. But of course, when it is positive, it means same signs according to the sign of the middle term. But there are situations and cases like this one where you don't have factors. If you don't, you don't. Then your thought should gravitate towards quadratic formula. And in the event that you get a negative sign inside the square root, that means there's no solution. Your calculator, you'll press and you'll get maths error. That maths error is speaking to the non-real nature of your roots, which means there's no solutions of x. Okay. So, dark-skinned, I'm proud of you. You did attempt to factorize. You saw that you attempted, ne? And also I think you also attempted because you are not mindful of this, same signs. How in the world, which factor, which factor, which two?
5. And
Aye, man, come on, guys. Yeah, you must be common sense. It's common sense, that one. So you must apply the common sense, guys, please. Otherwise, some of you are going to stuck. Some of you opening questions, you get stuck here. Hey, and you stay there. You camp there. You spend 5 minutes. You are like, Aibo, how's it? How can it be? And it's like, why? 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 When you don't have to.
Yeah.
Yo, your favorite.
Ngifuna ukubhalwa phansi. Hayi.
Uthi lena ifuna ukubhalwa phansi.
LCD. Oh.
Look at that. Someone is saying, can you do more questions on K method? Butu Lufuno, my guy, go to the textbook. The textbook is laced with repetition of expression. If you have that Mind Action Series textbook, there's literally a section of the quadratic equations, exercises that you can do on K method, because those are your repetition of the expression. So I unfortunately not in this live because we need to get the variety through. And there's someone here who has a specific curfew that she has set. So I have to make sure that we meet that curfew, at least having done a wide variety of questions. So I'm sorry, unfortunately, I won't be able to do other K method questions. Hopefully you get the concept. Here, I'm here to just remind you of the concept so that you can have the confidence to then go and find and do. Okay. Dark skinned. You? You are up. You are up.
So, layer 9 minus x squared.
Sizoyenza.
I think kumele like sishintshe kuzoba negative x squared plus 9 bese sizodivide ngo-negative 1 sekuzoba x squared minus 9 and so the equivalent of 2 squares.
Okay, so to me you are saying, okay, in other words, that our focus at the moment is Mr. Denominator and factorizing our denominator. That's the focus at the moment. Before anything, denominator focus, factorize if possible. And then the specific application you are making when there is that we need to apply the sign change rule. Ne?
Yes.
9 minus x squared, we apply the sign change rule. So let's see the application. So 2x over x minus 3, we change the plus to minus. That then allows us to, in the denominator, say x squared minus 9.
Yes.
Yeah, I just wanted to emphasize that point. Equal to x over 3, x over x plus 3. Okay, I am just going to fit that in there. Then, let's factorize. X minus 3, just going to write that in brackets, minus x minus 15. So give me the factorization of x squared minus 9, will you, Duck?
2 sets of brackets, x and x.
2 sets of brackets, x and x.
Plus minus 3 and 3.
Plus minus.
Is equal to x over x plus 3.
I'm just going to put that in brackets as well. Okay. The reason I do that is that from the denominator having 2 terms, I now have 1 term in the denominator because I'm putting the brackets around to show that in a way it's me taking out the invisible 1 as the highest common factor. Okay. That's step 1. Factorize the denominator if possible for all the fractions. Step 2 yena masesimbheka ufunani.
LCD.
Ameni girl. LCD. With what? There's something we need to accompany with the LCD. Okay, but anyways, it's fine. If you don't know what it is, or you are going to tell me, maybe it's just that me, I'm the way I am. Oh, there we go. Siyamthanda Kabula there in the comment section. LCD and your restrictions, ne?
Yes.
So LCD, give it to me. What's the LCD?
X plus 3.
X plus 3. Bracket, yes.
Into x minus 3.
Into x minus 3. 100% correct, my dear. X plus 3 into x minus 3. Restriction? We know most what we mean by restriction, eh, dark skin? With denominator, we don't want to have 0. So what are the values of x we must avoid having?
Oh.
Yeah. Hey.
Negative 3.
So x cannot be negative 3. Or what?
Or x is not equal to 3.
Yeah. That is our restrictions. So your LCD, please don't ever just write the LCD alone. Accompany it with the restrictions so that it sets the tone as to the x values we want to avoid having as our final answer at the end. Yandiv?
Yes.
Amen. Hallelujah. Next step. I think we're going nicely. Very well.
So multiplier throughout LCD.
Multiplier throughout by LCD. So when we do that to the first fraction, multiply by the LCD in the first fraction. Must be multiplying with this LCD in the numerator, right?
Yes.
So what happens in the
X
first fraction?
X minus 3 will cancel X minus 3. Then sizosala ngo-2x into X plus 3.
Yeah, there we go. So wacancela X minus 3 kwini, and then washiyeka X plus 3 with 2x. For the second term,
minus X into X minus 15.
Yo, nice one. Well played. Well played. Can I clap for you? Yeah. Many learners forget this bracket. If you have 2 or more terms in the numerator, please put those terms in brackets. Because if there's a negative sign, that negative sign is not just applicable to the x, it's applicable by multiplication to both x and negative 15. Hence, you put the brackets. So good job, Duck. Yo. Okay, then?
X plus 3 will cancel X plus 3. Then sizosala ngo-X into X minus 3.
Aye. You've got it. Then, so that was 3. We said we multiply each term in the numerator with the LCD. Why are we doing that? So that we can eliminate denominator. There is an intention, a mission that we are accomplishing by multiplying each term in the numerator with the LCD. It's to eliminate, want to get rid of the denominator so that fractions are gone. Fractions are a pain, right?
Yes.
Yeah.
FOIL. So about 2x squared.
2x squared
plus 6x
plus 6x. True, very good.
X
Minus x
plus 15
plus 15. That's true.
is equal to x squared
X squared
minus 3x
minus 3x. Good job.
Then sizothatha x squared minus 3x to the other side. This way.
X
So
squared
minus x squared
minus x squared. His like term is paired with him. Yes. Sign change. Yes. Plus 6x minus x plus 3x
plus 15
plus 15
equal to 0.
is equal to 0. Nice. Then
X squared plus 8
plus 8x
plus 15
plus 15
is equal to 0.
equal to 0. Nice.
2 sets of brackets.
Yebo.
So about x and x
And x.
plus
Very good. Plus indeed.
5 and 3.
5 and 3 is.
X is equal to negative 5 or x is equal to negative 3.
Yes.
Yeah.
And then?
X minus 3 as a solution.
Check your answer against the restriction. So we said x cannot be negative 3, therefore we still maintain that, meaning there's only one single solution. in this entire situation. It's x is equal to -5. So yes, step 4, after multiplying by the LCD, we simplify. 5, we get the standard form. 6, we factorize. 7, we apply the zero factor law. 8, we get the roots and we check against restriction. So all of these basically are the check step marks, okay, that we take whenever we are solving a fraction equation, from step 1 right up until step 8. Okay. The skinned. I'm telling you. Hello, sunshine.
Oh, root 1 minus 4x.
Root 1 minus 4x. Root 1 minus 4x
is equal to 2x plus 1.
Is equal to 2x
plus 1.
Plus 1. Aibo, why did you leave the square root alone?
Because in day 1.
Okay. All right.
Square both sides.
Okay. Yeah. It's like you're putting the poor square root, you're putting it in an isolation chamber, and then the next thing you are squaring it.
Yes. The square root and the 2 will cancel. This is Susala. 1 minus 4x is equal to 2x plus 1. Shall expand like.
Okay, 2x plus 1 shall expand. Yes. What do you get?
Well, 4x squared.
4x squared.
Plus 4x.
Plus 4x.
Plus 1.
Plus 1. Yeah, me, I like that for the grade 11s and 12s. The grade 11s and 12s at this stage should not be so like opening brackets, wasting time like that. They should be squaring the first term, squaring the last term, and then multiplying the product of the two, double it, so that they get the middle term. I expect such from grade 11s and 12s because we can't be wasting time opening brackets and it's time. Now we don't have time. We really don't have time.
4x squared plus 4x plus 4x.
4x squared plus 4x plus 4x.
Plus 1.
Plus 1.
Minus 1.
Minus 1.
Is equal to 0.
Is equal to 0.
1 and 1 will cancel. This is Susala of 4x squared plus 8x is equal to 0.
Nice.
So keep 4x as a common factor.
4x is a common factor.
So Susala x plus 4.
X plus?
Oh, x plus 2. So
Beautiful. I love your mistake, by the way. I love it. It's a common mistake, that one.
Is equal to 0.
Yeah. There are things called beautiful mistakes as dark skin.
Yes.
Yeah, the ones that you can teach people things because it happens.
4x is equal to 0.
Yeah, 4x is equal to 0 or?
X is equal to -2.
X is equal to -2.
Yes. 4x is equal to 0. Divide both sides by 4.
Okay.
Coefficient of x, 4 and 4 cancel. X is equal to 0.
Okay, then
Let's check ukuthi like right. Let's calculate.
you think that part, what you just said is the one. You check. You can check with your head more. 0.
0 la.
4 times 0 is 0. 1 minus 0 is 1. Square root of 1 is 1. 1 minus 1 is 0. If you take the 0 there, you get 0 this side as well. So 0 works. Ne?
Yes.
Negative 2 minus 4 times negative 2 is positive 8.
Positive 8 to 9.
Plus 1. 9.
Yes.
Square root of 9?
3.
3. 3 minus 1?
2.
2. But if you multiply the negative 2 with 2, there you get negative 4.
4.
Does it work?
No.
So x cannot be negative 2. We know it's just 0, mostly.
Yes.
Yeah. Third equation, 6 marks. Isolating the third. Squaring. Standard form. Factors. X is equal to 0. Negating the incorrect answer. That's 6 marks. We didn't mark this guy. 6 marks. Applying the sign change rule and factorizing this one. Remember that one here, you had the plus sign. We changed the plus to minus, and then we applied the sign change rule, x squared minus 9. That is a mark usually, right? Factorize the standard form, the factors, the two answers usually, right? Yeah, it's usually because these marks of the standard form are coming from the multiplying out. Okay, so sometimes they'll give you the mark for the LCD or the multiplying out, so it just depends. Okay, but like I honestly think that a question such as this shouldn't be even 6 marks. This one should be more. Icon. So they are measuring the marks. 8 marks, this one. K method. Standard form factors, the two equations respectively. Getting x has no solution, all right? And then the two values, x is equal to negative 2 and 1. Okay. Hello, inequalities.
Yo.
Don't go yo.
So sene ngikubuza ne. If like go 1 minus 4x.
Yes.
Kuyenzeka uthi like yabo 1 minus 4x is equal to 0 mhlambe bese iyayenzeka. So kuzoba x minus 4 bese kuba minus
So inside the bracket, what do you see? You see 1 minus 4x, the x term is negative. But here the x term is positive. So we don't want, it would be preferable if we actually can apply that change rule for the bracket. So we can actually do what? Take out the negative. Then write 4x minus 1. Ne?
Yes.
Then we divide by the negative. When we do that, what happens to Mr. Inequality?
Yeah, shit.
Exactly. Wa reversa. So that's beautiful. Now we are in the factor stage. After the factor stage, we need our critical values. Yeah. So what are our critical values? Because that would be comparable to getting the solutions if we're solving for an equation. So for these two, so what are our critical values? We write CV.
X is equal to 1/4.
Thank you.
Or X is equal to 4.
Beautiful. After the critical values, GR, graphical representation. So graphical representation? Isiphambano. Okay, so me, I love Mr. Parabola, eh? And then I usually gauge my parabola based on the two brackets, okay, where obviously the x terms were positive. So that means I have a concave up graph. That's the first thing. A critical value, the smallest one. Most critical values represent your roots. They represent your x-intercepts. So the smallest, U1/4, which is there. The biggest is 4, which is there. Akir, anditi, kunjalo phela, njalo mos. Or maybe I can ask you, how would you do it when you are here after the critical values? Because I heard you say it's combined, okay?
From 1/4, we are upwards, a positive lapho. Bese la below the x-axis, it can fit negative.
True.
Bese ngapha ku-4 kuya le upwards, a positive nakhona.
Beautiful.
So la sifuna la i-graph greater or equal to 0.
So greater means positive. Yes. Equal means on the x-axis. Okay, we can say at the critical value. Equal to 0 means at the critical value. Greater than 0 means positive for OY, which is also above the x-axis. So where does the answer lie then for O positive? Ngapha ne?
Yes.
And ngapha. That is for positive Y. So how do we write or represent the answer? And then O on means exactly equal. So how do we represent?
Equal to 1/4, but less than 4.
So we say what? X. Meaning lama value la kwelicala gama value anjani? 1/4. Are these values less than 1/4 or are they greater than 1/4? Values on this side of x of 1/4.
Greater than.
Okay, so let me repeat. Are these values smaller? The values on this side. If we are on the number line, this is 1/4. Values on this side of 1/4, are they smaller than 1/4 or are they greater than 1/4?
Greater than.
Never. So dark skinned, Nancy number line, beg, sheba. 1, 0, 1, 2, 3. Is 1 smaller than 2 or is it bigger? Is this number bigger than this one? This one. Yeah, this number is smaller than that one. So dark skin, we are looking at the x-axis, our real number x-axis. I'm just placing the x value, which is 1 over 4, and 4. 4 is the smallest value because on the number line, the smaller value is this side. The bigger value is on that side. That's why I put 1 over 4 here. I put 4 this side. So when you write your answer, if you are saying greater than 0 means where y is positive, you are talking about the y values, the y-axis. Obviously above the x-axis, your y values are positive. That's what greater than 0 means. So now, what are the x values that show above the x-axis? It is x less than this value, which is 1 over 4. So you can say x is less than. Are you with me?
Yes.
Less than, but also, since we said on the x-axis, it means also equal, meaning equal exactly to 1 over 4. So that's one answer. Okay. Or, do you want to tell me about this side? What are we going to write for this side?
Awungayibhala sis.
Hayi, angizuyibhala. Ngizoyifumana kuwena. These values that are on this side of 4, are they values that are bigger than 4 or are they less than 4? The values on this side.
Bigger than 4.
Exactly. So you are going to say x is bigger, greater than, or equal, because you are also looking at on, than who? Than 4. So if ever you are saying positive for this graph, greater than 0, you are always in essence saying values on this side of the critical value, which is 1 over 4, or whatever it is, and values of x that are on this side of these critical values, which are values that are bigger than this value. But if they had said less than 0, then of course you are going to talk about values that lie in between these two critical values. Okay? Yeah. So some people write the answer this way. Some people, they write the answer this way. Yeah. Because this represents this side from negative infinity to 1 over 4. We include 1 over 4. This means union, or from 4 to what? To infinity, open brackets. So some people write the answer in interval notation. So there are 2 ways to represent your answer at the end. So I hope even as you see your answer represented this way, you can see, oh, okay, so all the values of x that lie on this side show your y value, because you can see your graph here is positive. All the values on this side of 1 over 4. These are values that are less than 1 over 4. But then for equal to 0, this is exactly equal to 1 over 4. So at 1 over 4, we are equal to 0. In other words, y is 0. On this side of x, where the values are smaller than 1 over 4, the graph is positive. Y values are positive here.
Oh, so if like laphaya it was maybe greater than 0, laphaya 1 over 4, besingeke sim-include angithi.
Yes. If it was just greater than 0 without the equal sign, remember, as I said, you see, when I explained this to you, I said, greater than 0 means where y is positive. When you have the Cartesian plane, okay, as I said, this here represents the x-axis, this here. Then the graph as it increases and decreases, obviously we are talking about y. Y is positive only above the x-axis. Why are we saying y is positive only above the x-axis? Because your y values that are positive are situated here only. All right?
Yes.
Yeah. So then if you have equal means on the x-axis, exactly on the x-axis. So that's why, for instance, if we have equal to 0, I am also not just checking greater than 0 alone. Yes, greater than 0 is obviously going to be checked, but also additionally, I'm checking at or on the x-axis, because equal to 0 means that. So I have to include the critical values because they are the ones that are on the x-axis. After all, I said a critical value is your x-intercept as well. We call it an x-intercept or a root, the root of the equation. That's what a critical value is. It's an x-intercept, or you can also refer to it as the root of the equation. Okay, so yeah, I hope that's really helpful for you, because yeah, if there was no equal, we are just focusing on greater than 0. So we would have just said x is less than 1 over 4, no equal sign. X is greater than 4, no equal sign.
Okay.
Yeah. Then if, let's say, this inequality had said less than 0, how would that have effect? Let's just say, I'm just going to write this out here. Let's say it was 4x minus 1 into x minus 4, and then it said less than 0. Now, less than 0, as you explained, I think you explained this, that less than 0 means below. Yeah, the x-axis, right? So if you are to sketch, you're going to have your concave up graph. You have 1 over 4 here, you have 4 there. The answer is obviously going to be situated below. Below means between. I usually say below the x-axis, between the critical values. This one, we say AA because above the x-axis means away on this side of the critical value, away on this side of the critical value. And so anyways, below and between, so that means x is in the middle. X is greater than 1 over 4, but less than 4. So you write a compound inequality as a representation of your answer. Okay. But if there was an equal sign, you would include the 1 over 4 and include the 4. Because you're not only looking at below the x-axis, you are looking at equal, meaning on the x-axis. Okay? Yeah. Or you could have just written the answer in interval notation, 1 over 4 to 4, open brackets. If there was an equal sign, then of course there would have been equal sign here, interval notation, you would have put square brackets. Okay. So any questions further, dark skinned?
Ayabonga right.
No, if that's fine, that's fine. Yeah, because inequalities, remember, inequalities have they also then have an influence on your functions. So the thing is, if inequalities are not understood from the basis of the graphical representation, because we personally, I'm not gonna lie, whenever I teach inequalities, I emphasize the graphical representation as a parabola. Why? Because I'm anticipating that when I start teaching functions and I talk about the parabola, then we are going to have those questions that says, for which values of x is f of x greater than or equal to 0? And I mean, all that this is asking for, it's asking for the very same thing for the parabola that you have sketched. Where is the function greater than 0? In other words, where is y positive for the function? Which x values show the y value, the function having positive y values? And then where is the function on the x-axis? Okay. And I mean, that's pretty much what you are asking as well. Then those interpretation questions, they actually are not not difficult at all. They are very easy when the understanding is there of that. Thank you, Sasa, for the hot me. Thank you so much joining the fan club. Really appreciate it. Yeah, I guess this one is for you. They created it for you.
Oh.
Did you just say?
Hey. 4x squared minus 1 is less or equal to 0.
Thank you. Then?
2 sets of brackets.
2 sets of brackets.
2x, 2x. Plus 1 minus 1.
Yes.
Is less or equal to 0.
Yes.
Or x is equal to negative 1 over 2.
Okay, so what are you going to write before you write that?
Oh, critical values.
Thank you. You better write that. Otherwise, hey, smack.
Critical values, x is equal to negative 1 over 2, or x is equal to 1 over 2.
Thank you. Then?
Parabola, exactly.
Parabola. Small, big.
So, let's do that. I feel like the solution is in between. X is an element of negative infinity is to negative 1 over 2.
Before that, let's interpret this before you jump in and answer. What does less than or equal to 0 mean again? Less than 0?
Below the x-axis.
Below the x-axis. So below the x-axis, where is that? So below, and below means below, between. So?
And equal to 0, we should say on the x-axis.
On the x-axis, exactly. So, you can write your answer now.
Negative infinity is to negative 1 over 2. Negative 1 over 2 are we included because can equal to 0.
That's where I said you need to be careful. You're talking about negative infinity, but your shaded region does not even talk about negative infinity. Below, in between these two values.
Oh.
Yeah.
Negative 1 over 2 is to 1 over 2.
Negative 1 over 2 to 1 over 2. How are our brackets? Thank you, Sasa, for you awesomes. Thank you so much, brother.
Square brackets.
Yeah. Hey, Ngwana. Be careful. That's why I was saying to you, be careful.
Yes.
Yeah. Because below dark skin, below, between. You see, the way I've shaded, the restriction is from here to there. Are you with me? Because where y is negative is below the x-axis. But what are the x values that are showing this belowness? It's from negative 1 over 2 to 1 over 2. That's where we see y being negative. Now, if you are going to say to me, negative infinity, Haibo, we are positive mostly. Negative infinity. Okay? Yeah. Are you with me, Toxin?
Yes.
Like, are you sure? Are you sure you are with me?
Yes.
Yeah. Okay. Like I said, the people are asking if we're doing all the questions. Not me. I'm just, like I said, I'm going to follow my leader. If my leader says stop, I'll stop. Dark skin has the reins. Yes, window greater than 0 means above the x-axis because that's where y is positive. Less than 0 means below the x-axis. That's where y is negative. Okay, so dark skin with this one. Any thoughts? They're saying if x is equal to 1 and x is equal to negative 4 at the roots of the equation, determine the values of b and c. Any thoughts? No problem. Okay, I'll give you Gangan, don't worry. I'll give you Gangan.
Angeke sicele si-equate like u-1 then
Okay, so what do you mean by that? Okay, so there are two ways to answer this question. Okay, Black Teddy in the comment section said, start with substitution. Remember, if they are saying x is equal to 1, you could take the 1 and substitute here. Ankiri, they are saying it's a root. What is the root? It is one of the solutions of this equation. So that means you can take the x, substitute it here. So if x is equal to 1, in the place of x, we say 3 times 1 squared plus b1 plus c is equal to 0. So we get 3 plus b plus c is equal to 0. So your first equation 1, b plus c is equal to negative 3. Take the second root, x is equal to 4. Do the substitution there as well. 3 into 4 squared plus b4 plus C. Ne? Are we following?
Yes.
Then you can say 4 squared is 16. 16 times 3 is 48 plus 4b plus c is equal to 0. Then, of course, you have a second equation. Okay. Yeah. 4b plus c is equal to negative 48. That is equation 2. Then you can solve these two simultaneously. You have two linear equations that have unknowns of b and c. Remember was it grade 10? Solve for x and y.
Yes. 10.
But it's just that you have b and c. You have a linear equation. Okay. Oh, sorry, negative 4. Sorry, guys. My mistake. I didn't see that. X is equal to negative 4. I made a mistake of substituting positive 4.
48.
So that should be negative 4b. That should be negative 4b. Okay, I think that's the only omission. Negative 4b plus c is equal to negative 48. Thank you there. Comment section, very alert. Very alert. That makes me smile. Very alert, the comment section. People are very alert in what's happening here. So if you take, let's say b, make b the subject for this equation, you get
negative 3 minus c.
Minus c. So that's our equation 3. We are going to substitute that equation 3 into 2. So then we are going to have minus 4. In the place of b, we are going to substitute minus 3.
Minus
C.
Plus
the c.
Negative 48.
Yeah. Then we can distribute that.
12 plus 4c plus c.
Ne?
12 or 5c is equals to negative.
12 minus 12 minus 48 gives us negative 60. Then we divide both sides. We get c is equal to negative 12. Take the negative 12, substitute it there. Are we together there?
Yes.
And then we get an answer of negative 3 plus 12, which is 9. So there is the b and c, because they wanted us to determine the value of b and c. Okay, so go back to the concept. The concept is that they said if x is equal to 1 and x is equal to negative 4 are what? Are the roots of this equation. Determine the value of b and c. So do you understand why we substitute x is equal to 1 into the equation alone? We got an expression, or an equation in terms of b and c. And then we took the other x value, negative 4. We substituted alone into the equation again to get another equation in terms of b and c. Then we solved them simultaneously. Make sense?
Yes.
Yeah. There is another quicker method, to be honest. There's another quicker, shorter method that's even shorter than that one. Uh, have you ever seen how we can move from the solution back to the equation in a problem? So let's just say we had x is equal to 4 and x is equal to negative 4. Let's work backwards. From the solution, the roots, let's move to the factors. Let's transpose 1 back. We get what? X minus 1, right? Equal to 0. Okay. Then from the roots to the zero factor law back to the factors, that means we have x minus 1 into x plus 4, which is equal to 0. Okay, we're working backwards from the roots back to the equation. Make sense, ne?
Yes.
Then we expand x squared plus 4x minus x will give us plus 3x.
X.
Okay, minus 4.
Minus 4.
Then we come here, we look at the equation, how it was represented. They said, are the roots of the equation 3? There's a coefficient of x squared, which is 3. So that means we can go to this equation and multiply both sides by 3. Because in an equation, what you do on the left, you do on the right. So 3x squared plus 9x minus 12 is equal to 0. So what is the value of B? 9. What's the value of C? Negative 12. So that's another method. Okay. My goodness. Midnight conversations. Okay, I'm just going to 1.3 solve for x in terms of p. Okay. Yeah. Okay. Standard form, quadratic formula. You solve for x in terms of p. Your answer is going to have a value of, you're gonna get a solution, but it's going to have p in the expression, not just a number value. Okay. So standard form, quadratic formula, because you'll need the quadratic formula here and you solve. Okay, I'm not gonna go into it. 1.4, very common this one. If x plus 1 over x equal to root 3, determine without solving the equation the value of x squared plus 1 over x squared. Have you been exposed to a question like this before, dark skin?
No.
Yeah, but this one is very nice. You square both sides. Okay, you square this side, you square that side, and then yeah, you play around with what you've squared. Because obviously squaring means you FOIL. Squaring doesn't mean you square the first term and the last term. So for instance, x plus 1 over x is what you've been given. So what I'm saying is that you are going to square this side and you are going to square that side as well. And when you do that, you remember what I said, you square the first term you square the last term. You multiply these two. When you multiply these two, what do you get? You get x divided by x, which is 1. You double it. You get 2. Ne? You square the first term. You square the last term for the last term.
Yes.
You multiply these two. What's x times 1 over x? Isn't it 1? Because this x and the x will cancel. Then you double it. So the expansion, so you could go ahead and open two brackets if you want to actually do that, and you can multiply out that way. This side, what is the square root of the square? Ne?
Yes.
Then you isolate the expression x squared plus 1 squared. You take the 2 over. What's 3 minus 2?
1.
So the value of x squared plus 1 over x squared is what?
Is 1.
Yeah. So let's just check this question again. It's saying if x plus 1 over x is equal to root 3, determine without solving the equation the value of the expression x squared plus 1 over x squared. So I took this. Why did I square it? Because I saw that the expression that I needed the value of is having an x squared followed by 1 over x squared. So I squared the entire term. I get the 3 terms. Then I take the 2 over, because 3 minus 2 is going to give me a value whose expression I'm looking for, which is 1. Okay?
Yes.
Yeah. And as I said, this one, solve for x in terms of p. Use the quadratic one. 1.5.1, 1.5.2, 1.5.3, they are all simultaneous equations. Have you ever seen a simultaneous equation that you need to solve that's like this?
No.
Like that?
No.
Like this?
Yes.
You see. So these are unfamiliar, but this one is very familiar. So
Yes.
I'm sure you will be able to do this one, no doubt.
Yes.
Okay. This one, when you have a product of factors and there's a 0 on the other side, don't we apply what we call the zero factor law? You have a product of factors. You have equal to 0 on the other side. You can take the first bracket, equate it to 0. Or take the second bracket, equate it to 0. We are going to stop this one and take care of this one because we can get the value of x for this one. Ne?
Yes.
I'm sure you can. Once you get those x values, then you will take them and substitute them where? Here. So that you can get your y values.
Okay.
So it looks like it's a complicated problem, but it's not actually, because all we are doing here is we are applying product of factors equated to 0. We apply the zero factor law, and then we solve the one that is solvable. After getting it, we can substitute into the other. If we get 2 values of x, we're going to take those 2 values of x, substitute the one value, get the one y value, and then substitute the other value, get the other y value. Okay?
Yes.
That's if the y value is possible, because we're going to have to check if the y value is going to be possible or feasible when we do the substitution. Okay, so I'm not going to finish this one. I think you get the point. The concept is clear. It's just the application of the zero factor law. It's just that you, unlike any other, it's just that you have y and x in the mix. So you first solve the one that is doable, and then you use the answers to then substitute and get the other values.
Okay.
Can we put that one to bed?
Yes.
Okay, then this one. Very unfamiliar. But look at it, ne? If you forget about the expressions, what two numbers can we add together which will give us that will give us 0? That is the $1,000,000 question. What are because how many terms do you have on the left? You have 2, right?
Yes.
And each bracket for your 2 terms is squared. Okay. So the easy, quick approach is to actually take your first bracket. All right. Okay. You take your first bracket. You take that first bracket, which is x minus 1. You see, Sasa there in the comment section is saying 0 plus 0 is equal to 0. You take the first bracket, you equate it to 0. But then you're not going to say or. You're not going to say or. You are going to say and. And the reason why we say and is because of the plus sign. Okay, if we have a product of factors, we use or, because the zero factor law says if a times b is equal to 0, then a is equal to 0 or b is equal to 0. For this one, we are going to say x minus 1, the whole thing squared, is equal to 0, and 4y plus 2, 4y, the whole thing squared, is equal to 0. 4y plus 2, the whole thing squared, is equal to 0. We put and. This and is very important for it to feature because of there being a plus sign in between the 2 brackets. Or if there was a minus sign as well, you'd still put what? And. Then you can solve this one on its own. Obviously, this will give you x is equal to 1. Straightforward. Okay? And this one, you solve it also independently. You can take the square root on both sides. You are going to be left with 4y plus 2 is equal to 0. You isolate the 4y. You take the 2 over. You divide by 4. You get y is equal to negative half. So these are the 2 values. So you take both. When you are checking, you have to actually substitute them simultaneously. You don't take one and hope that that one is going to satisfy the equation on its own. Okay? Because the and means both need to be featuring in the equation in order for the equation to be satisfied. For 1.4.1, the whole idea of or is that you can take only one x value at one of the values at a time, and that will satisfy the equation. There's no need for them both to be substituted. All right, one at a time is enough. But this one and I both need to be substituted, okay, at the same time. So I hope that gives you new insight for 1.4.1, 1.5.1, and 1.5.2. I'm not going to get into this because I'm expecting everyone in this live lesson to know your first mark, making x or y the subject for the linear equation. That's your first mark. Then substituting that third equation into the other equation for your subject. Then you multiply out, you expand, you simplify, you get to standard form. From standard form, you factorize. If you can't factorize, you use the quadratic formula. Then you get your values of whatever variable you were solving for. If it was x, you get your values of x. If it was y, you get your values of y. If, let's say, for instance, you use the quadratic formula and you were busy with a equation with y, please, your subject of the quadratic formula cannot be x. Yeah, that one is a big one. If you were busy with an equation that has y, and then you decide, let's use the quadratic formula, please, guys, remember the letter you are working with. Remember the letter you were working with. Otherwise, it's so sad when you see learners, they are working with y, the standard form is in terms of y, then they use the quadratic formula because they cannot factorize, then they say x is equal to, and then they end up getting the x value for a y equation. Sabotage. Okay, and then the last thing, you make sure you get your y values. After you get your y values, you go and substitute back into the third equation to get your x values. Because it's also another thing that is very sad, that learners will solve for one variable and not solve for the other, but it's a simultaneous equation. So I'm not going to go into that, the specifics. I think I guys know, you know what you know. You know what you should know. Or at least you should know what you should know. So the question is, dark-skinned, I am wondering, is there anything else that's on your mind right now?
No, sesh. Mara hyperbola. Yo.
Itheni hyperbola?
The tricky so.
What is tricky about the hyperbola when that graph is so beautiful? Okay, so let's just talk about it very quickly before I bounce out of here. Y is equal to a over x plus p plus q. Beautiful function, this one. When a is greater than 0, what do you know?
Amalo, magraph wakho azoba ku first naku third.
Okay, so your odd number quadrants, 1 and 3. Okay, yeah, and your quadrants are defined according to your what? Your asymptotes, ne?
Yes.
Yeah. So when we say first, we are saying the first quadrant of the asymptote. And when we say third, we say the third quadrant of the asymptote. It goes without saying. Ne?
Yes.
A less than 0?
Second quadrant. Naku
Yeah.
fourth.
So your even quadrants. And that is second and fourth, in other words. So second, so once again, you have your horizontal asymptote, your vertical asymptote. So we are operating with your second and fourth. Okay, that is your hyperbola. And the one other thing is that we know that this function, when a is greater than 0, this is a decreasing function. It decreases everywhere for our domain. You can see what's going down. It's going down.
Yes.
This one is an increasing function. It increases everywhere for your domain. Going up. Okay. Yeah. Then there's this thing, range and domain. for these two functions, for basically the function itself. The range, what is range? Dark skin.
I-range ngazi ukuthi sibheka ama-y values.
Y values from the bottom to the top. And mostly that's along the y-axis from the bottom to the top. That is our range. Your y values from the bottom to the top, where the function exists. It exists from the bottom to the top. Domain?
X values.
Yeah, so X values.
Left.
And you are saying from left
Right.
to right. Yeah. Function exists from left to right. So generally speaking, in a typical hyperbola, your range is always what? You should know this. Your range, just generally.
X is Y is an element of real numbers.
But?
But not equal to ban.
I don't say don't equal to ban. You must be specific. Ban. Who's ban? Horizontal asymptote? Y cannot be the Q value. Yeah. So remember, what is an asymptote? What is an asymptote by definition, Daxki? Asymptote, what is it?
Mara yona ayithinti graph.
Ayithinti ha, wathinti umfazi, wathinti imbokodo, ayithinti. I like that, ayithinti. Okay, so asymptote ayithinti. Ayithinti. Asymptoli. Asymptoti. Ayithinti. Asymptoli. Asymptote. So the function cannot be tolagald. The function cannot be tolagald. The untouchable line, the boundary line. Dark-skinned.
Sir.
If ever I will share anything with you, I hope that you will hold this, what I'm about to share, very, 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 very near and dear to your heart. Listen to me very well. In life, you must be like the hyperbola. Okay? Because there are places, there are things that you should never be tolagald in.
Yes.
Yeah. The thing is, if the hyperbola did not have asymptotes, then its identity as a hyperbola would be compromised. But because it has boundaries, there are places, areas where it is not found, it is able to retain its pure identity. Boundaries, untouchable places. As an individual, you should have those. Lines should be drawn. If you look at this arm, for instance, this line or this graph, it approaches the line, but it never touches. So you should have those as an individual. boundaries, untouchables. You just declare it there and there that these are untouchables. We don't go there. So asymptotically, yeah, yeah. So asymptote. I hope that makes the point about asymptote. So your hyperbola has two asymptotes. There's a horizontal one. As if that's not enough, it has to have a vertical one as well. Right? And as a horizontal line, when you learned about your equations of straight lines, you know that a horizontal line has the equation y is equal to a particular constant. Okay?
Yes.
Then here, your vertical line, as you learned when you did straight lines, even in grade 9, if they did a proper job in grade 9 earlier grades, you know that when a vertical line is represented in equation form, it is in the form of x is equal to p, because the gradient of a vertical line is undefined. So that's important. So your asymptotes are your untouchable boundary lines. Asymptotally function lapayana. So therefore, when we write the range of the function, we say that the range is the possible y values from bottom to the top where the function exists. Where does the function exist? It exists, this thing, everywhere. ER, element of R. This means everywhere. For every y value imaginable, except exceptions, the boundary line. You will never find it there. Domain. So what is the domain of your hyperbola function, generally speaking, dark skin?
X is an element of real numbers where x is not equal to p.
Everywhere but the boundary, from left to right. Ne?
Yes.
Yeah, so I know that Mr. Hyperbola also has, what do we call this thing?
Axis of symmetry.
Amen. Axis of symmetry. There is two. One has a positive gradient. So the AOS, the axis of symmetry. Okay. The AOS, the positive gradient, and the negative gradient, axis of symmetry. And to be honest, the positive gradient is always positive 1 within the confines of the syllabus that we do. The negative gradient axis of symmetry is always negative 1. Okay? Does that make sense?
Yes.
Then your general form of the function for your axis of symmetry is always given by, do you see this expression here? This one?
Yes.
It's the one that belongs here. Do you see the Q here?
Yes.
It's the one that belongs here. So if you want the equation of your positive gradient axis of symmetry, all you do, my dear, y is equal to, you put your gradient, because as I said, your gradient for the positive gradient axis of symmetry is always positive 1. It doesn't change. 1 that is positive. That belongs there. You product it with the expression in the denominator, and then you add or subtract whatever is there at the Q value. And there you basically then distribute whatever is there. You get the equation in the form of y is equal to ax plus q, because it's a straight line. Okay. Distribute, multiply out. That's how you get the equation for the positive gradient x of symmetry. They ask you for the negative, same thing. -1, you see the expression in the denominator, you write it as it is, whatever it is, brackets, you add the q, and then you play a distribution game, and you get your equation in that form. Okay, does that make sense?
Yes.
So axis of symmetry is kind of like that. So if we are to be honest, then the only other thing is the translation of the function, your hyperbola, which basically translation affects all the graphs in the same way. When p is greater than 0, we say the function is shifting in which direction, my girl? If we're talking about p.
Greater than.
Yeah, greater than 0. P is greater than 0. Which direction are we moving?
To the right.
To the left, to the left. Everything you own in the box, to the left. Not to the right, but to the left. Yeah. Can I tell you something? I know everyone that thinks about it logically says that when p is greater than 0 is to the right. Logically, right? Yes, logically. Like, think about it. Kaloku to the right, say. I mean, say, to the right. But you see, the thing is, there's this word that I want to leave with you. Maybe you've seen it, you've been exposed. The word counterintuitive. Ne?
Yes.
Have you heard of it before? Counterintuitive?
Yes.
So the word counter is a prefix in English that means against. Intuitive has to do with thought or thinking. So counter means against thought, against the natural, logical thought process. So P is such a parameter when it comes to all the functions. Well, let me not say all. Parabola, exponential, and quadrant. Parabola, exponential, and the hyperbola are the three functions that have P affecting the horizontal movement of the graph. So P is counterintuitive, right? Meaning what you would normally think it means when you say greater than 0 is not what it actually means for P. So I expected you, I mean, dark skin, if let's say you were taught functions, and let's say for some reason or another you have forgotten, I expect any learner, when I ask them, P greater than 0, which side are we moving? I expect a learner to say to me, to the left, to the right. I'm expecting it because naturally, when you think about it, you think to the right. But now I need you to take this into consideration, that our P value is counterintuitive. Therefore, if P is greater than 0, we are saying to the left. If P is less than 0,
To the right.
Yeah, to the right. Now that is to the right. So it's only P that is counterintuitive. So this guy, is counterintuitive. Q, on the other hand, if we say Q is greater than 0, what do we mean? Dark skinned? You should know this one. This one is your cup of cake, cup of tea. All day, every day. So P we've already addressed. Left, right.
Upwards.
So OQ?
Upwards.
Yeah, I know it's up. I agree. Q less than 0?
Down.
Yeah, you can see here there's nothing about being counterintuitive, right? It is what it is. Okay, it is what it is. So, yeah, if they do anything, so if you add to P some more, the more you add, the more we are moving to the left. The more we subtract from P, the more we are moving to the right, by however many units that we are adding by. If we are adding to Q, we are moving up and up. If we are subtracting from Q, we are moving down and down. And this P and Q applies for all the other functions, exponential and parabol. The same logic is true for those functions as well. Yeah?
Yes.
Yeah. So I don't know, my girl, what it is. The other things, maybe I don't know. Maybe what other things you feel like are an issue for you where the hyperbola is concerned.
Right. Sesengiyayikhetha yabo. Yes.
Sorry.
Yeah. Esikoleni bebangakayenzi manje ish.
Kodwa it's coming out in the exam.
Abaqedanga isyllabus. So.
Oh, okay. No, I hear you. Well, I guess I hear what you are saying. So now I think what we need is some exam type questions on this thing. Unless you are saying to me, hey, because I can actually hear your voice, but hey, Aisha, you are tired, you are pellaring.
Yeah. No, so ngayenza. Ayinalo.
Of course. Ngayenza. I said. Are you sure? Are you sure when you are up to it?
Yes. Sure.
Okay, I'm just trying to find, because I think what I did, I just need to find, because the paper I was doing only has equations and nature of roots. Nature. So I need to just find the paper that has some functions grade level. Yeah, so here's another thing about hyperbola. Romeo, Wankolota, Romeo. Thank you so much, Romeo, for the roses. 23, Baba. Ay. Wena, Kista, Baba, Kista. Also, I think to Romeo, was also 2 kiss. Oh man. I think this time of night is not such a good time. Let's check this out. Look at this. Have you seen such a thing?
No.
I'm a hyperbole. Sesinikwe hyperbola la. But the form of a hyperbola is not the form that you are used to, my dear.
Yes.
Okay, so don't worry, we are going to unpack it when, yeah. Yes, that's why we are here, man. We are here to do these things so that people can be clear. So let me just try and get one paper here. I can work on, yeah, here. So in this question, we're dark skin, they are saying, given f of x is equal to x plus 4 over x minus 2, show that f of x can be written in the form f of x is equal to 6 over x minus 2 plus 1. So this is an unconventional way because e hyperbola can also be expressed in this form. Okay. And we need to also know how to change this form back to its standard form that we know. Yeah.
Yes.
So now we have a situation here where we have x plus 4 over x minus 2. And they are saying, show that f of x can be written in this form. So check what I do here, dark skinned. Here's f of x. I have x plus 4 over x minus 2. You see this x minus 2, you can see most that it has to be there for my final answer. Ne?
Yes.
Yeah. And the coefficient of x, it's nice here because it's 1. So we are very safe here. What we are going to do, you see this x minus 2, I'm going to write it down in the denominator. And then at the top, I'm going to write the same x minus 2. Okay.
Why?
I want this x minus 2 to still be there at the end because it needs to be there at the end still. So what I do is I write x minus 2 in the denominator still, and then at the top I write another what? X minus 2. Dark skinned, if I say what is x minus 2 divided by x minus 2, what do I get, my dear?
1.
Yes. You see, look. You see this guy? You see?
Oh.
Yeah. But let's not get too excited. Let's calm down. Let's breathe. All right. Then we are going to ask, what number should we add to negative 2 to get 4? You tell me.
6.
6, ne?
Yes.
Then I'm going to extend this line to 6 so that I have x minus 2 plus 6 over x minus 2. Did I change anything? Is the equation still the same equation? I mean, the function, it's still the same. This x plus 4 over x minus 2 is still there. Yeah, because if I just say 6 minus 2, I get back the 4, ne?
Yes.
So far we are safe. Then, listen, Gengoku. You remember that when we are talking about fractions, we only add fractions when the denominators for those fractions are what? Are the same. Ne?
Yes.
So I'm going to do this. I'm going to split this fraction. X minus 2 over x minus 2 and separate the 6 to be over what? X minus 2. Are we together? I've not changed anything, Moss.
Yes.
Yeah, the function is still the function. I'm applying some maths so that I can separate.
Yes.
Now we can simplify this side. What's x minus 2 divided by x minus 2?
1
plus 6 over what?
over x minus 2.
So I have f of x, which is the hyperbola function.
Mm.
Yeah.
Yes.
Then I just do this thing. Addition in mathematics is commutative. So the 6 I'm going to write first because I want the form to be the same form. The 1 is positive plus 1. So that's f of x. That's shown. I showed them. Show them, show them, show them. Thank you, Sakameze, for the popular, and thank you for the gifts, guys. Really appreciate it. You too kind. Too much kindness. My heart beats for you. All right, there we go. All right, there we have it. Okay.
Yes. If A bekungasi 1, mhlambe beku 4 or 3.
If it's like that, then obviously there are other critical, critical approaches that we need to take to ensure that we are able to maintain that thing. You see, so I let me look for. Hey, is that sometimes let me just check if I have a question that could, because obviously it needs to be an appropriate question. Let me just check. Just give me a sec. Just gonna check here somewhere quickly and I'll be with you just now.
What's that so? Lawa phone. Yo.
What's happening?
No, so yes.
Okay. You just okay, here we are. We have g of x is equal to 6 x plus 38 over x plus 5. And they say show that I think we just need to zoom out there. Show that g of x is equal to 8 over x plus 5 plus 6. Okay, are we together there?
Yes.
See, now the coefficient of x is 6, which is a pain. Oof. Pain of our lives. Okay, are you ready for this?
Yes.
Yeah, okay. So what we do, as I said, Moss, we x plus 5 over x plus 5. Okay?
Yes.
Yeah, we x plus 5 over x plus 5 because the x plus 5 over x plus 5 is surety, right? It kind of like gives us a sense of like, hi, things will be fine. Then we know that the coefficient of x here is 6. So what we are going to do is we are going to take out, or we are going to put brackets around the x plus 5. Then we are going to write the 6 outside that bracket. Now, if I say 6 times x, I get 6x, right?
Yes.
If I say 6 times 5, I get 30. So in my head, I'm like, I know I have 30, but what do I add to 30? Oh, my soul, what's happening? What do I add to 30 to get 8? My soul, what's happening? Go.
Plus 8. Plus 8.
Exactly. Plus 8. What in the world? Are you with me?
Yes.
Yeah. So in the same way that I basically used x minus 2 to write a fraction that is x minus 2 over x minus 2 and set that up. Here, I can see that the coefficient of x is 6. So that means my x plus 5 and x plus 5 mission is going to continue, no doubt. I'm going to keep that there. But then now it's a matter of getting the coefficient sorted as well. So I'm going to multiply. I'm going to put a bracket around the x plus 5 and I'm going to multiply the 6 outside the bracket for this binomial term. Okay? Then I'm going to say in my head, what's 6 times x? I'm getting 6x. 6 times 5 is 30. But to get 38, what needs to happen to the 30? I'm going to add 8. Ne? Yeah. Then I can go ahead and split this into these two.
Plus 8 over x plus 5.
Ne?
Yes.
Then these two cancel. I'm left with 6 plus 8 over x plus 5. Addition is commutative, so I can then write 8 over x plus 5 plus 6. That is going to be my g of x. Okay. So that shouldn't be a hold up, a hold back, because yeah, if it is, it will basically mean that you are forfeiting marks that are due to you that should be yours. Okay, so that shouldn't throw you back. I'm saying it is doable. The next question says, determine the equations of the asymptotes of f. Now, if you could not move out of here and get this form, that's okay, because of course you just forfeit the 3 marks. But the 2 marks, of course, the equations of the asymptotes you can write. So what are the equations of the asymptotes?
X is equal to 2.
And that x is equal to is which asymptote, my dear?
Vertical.
Yes, true. Thank you so much. It's the vertical asymptote. Okay, then?
And y is equal to 1 horizontal.
Awesome. Yeah, that's the horizontal asymptote. Yeah, just make sure you do indeed make sure the subject of that equation is there so that you can write down the actual equation. X is equal to y is equal to 1. Okay, and then sketching it, you would be able to sketch, no problem.
Yes.
Okay, so you are able to sketch. And if I said to you, find the equations of the horizontal, sorry, no. So if I said to you after that, after sketching, determine the range and the domain, you would be able to determine the range and the domain.
Yes.
Write down the equations of the positive gradient axis of symmetry and negative gradient axis of symmetry.
Yes.
So you see, like, I think like basically the basic fundamental questions must you, for the hyperbola, you would be able to answer most. Right? Domain and range, for which values of x is the function increasing, decreasing. What other questions are there for the hyperbola? Yeah. Then of course there's the interpretation questions for all the functions, of course, that don't get asked. Okay. Yeah. So I don't know if there's anything else that you potentially would like to check out. So that's a parabola there. That's an exponential there. So I don't know how, are you doing all functions? Guys, answering all functions.
Yeah.
That is your quadratic and linear.
Parabola, sharp.
Hyperbola. Okay. So noko iyazwakala kancane ke then le hyperbola.
No, ngiyayizwa ngiyayizwa.
Okay. Okay then. Exponents, surds, equations, nature of roots, you good?
Yes.
Okay. Okay then. If there's nothing else really and truly that's pressing, then my girl, I don't know what else. Okay. Yeah.
Yabonga seko. Yazi hyperbola. Mara sengiyayibona, ngiyabonga.
Yeah, no, that's fine. Hyperbola should be seen. Yeah, don't forget. I'm sure you see now at least you have a lot there. Asymptote,
Yes.
yeah. Akatholakala.
Namhlanje uzoyenza
Ini ke manje?
live like namhlanje.
Namhlanje ngibhizi manje ngibhizi. Namhlanje.
Le yabo 10, 11, 9.
Oh, you mean late again tonight?
Yes.
Do you mean that? Do you mean later on tonight again?
Yes.
Yeah. I'll be live again later on tonight because must see the grade 11s and grade 12s always want some help. And And the thing is, I know tonight it's not only going to be grade 11s alone, grade 12s. Grade 12. The thing is, grade 12s are writing as well on Friday. Some of them are writing Friday. So everybody wants this, wants that, calculus. You can see even Star Black there in the comment section. Say, can we do calculus tomorrow for grade 12s?
Yeah.
Yeah, because calculus, it's one of those nice topics that they love, the grade 12s. They are obsessed with it. Yeah. But there's nothing even there in that topic. There's nothing to it, man. It's a nice topic. It's a beautiful topic, that one. It's a beautiful topic.
Why?
Yeah.
Okay, yeah,
Let's just before I'm seeing something here. Just before you leave, let's see if you can. I'm seeing a question that's similar to this one that I just asked you now. It's a hyperbola. F of x is equal to x plus 3 over x plus 1. Show that. Can you do this before you leave? And then I can say I get at least I know. F of x is equal to x plus 3 over x plus 1. Show that f of x is equal to 2 over x plus 1. That's the first question. Second question, sketch. Let's make you work before you leave me. Let's make you work. Sketch the graph, indicate all asymptotes and intercepts. Yeah, and I'm sorry if I'm literally catching you an off guard. 3, write down the range of f of x plus 2. 4, write down the equation of h of x, where h of x is equal to f of x plus 2 minus 4. So if you can answer this for me before you vamos, I'll be happy. Yeah. Nice.
So it's about x plus 1 over x plus 1. Basic is about minus 1.
Okay, so x plus 1 over x
Over
plus
x.
1.
Basic is about plus 2.
Sebongu plus 2. Very good, very nice, very nice.
Basic is about plus 1.
What then?
May say that like ngizohlukanisa. So about x plus 1 over x plus 1 plus 2 over x plus 1. X plus 1 over x plus 1 is 1. Plus 2 over x plus 1. Then, therefore, f of x is equal to 2 over x plus 1 plus 1.
I will. Star. Okay, yes, nice.
Question 2, 10. Write down.
Question 2, uti sketch. Ufuni sketch.
Oh.
Sketch the graph, indicate all asymptotes and intercepts. Obviously, and this is born sketch circle, but it's fine.
Vertical asymptote. Negative 1.
Yes.
Bese horizontal zoba 1.
Wait.
Point.
So le horizontal asymptote yakho uthenga 1, that's all. You didn't say
positive 1.
The equation. No, I'm just saying the equation. When you say it's 1, do you say y is equal to 1? Because it's important. Y is equal to 1.
Oh.
Yeah, then vertical x is equal to. You must write it as an equation.
Okay.
Yeah, because if you don't, then you can stand the chance of it not being acknowledged. So the asymptote is an equation. Because it's a horizontal line, then its y is equal to for a horizontal line. If it's the vertical line, its x is equal to.
Okay, my bad. Yes, bese ke ngizoyenza ke.
Sorry?
Mengiceda bese okay. Number ngiqhubeke Ngiqhubekele ku-number 3. Write down a range of f of x plus 2. Y is an element of real numbers, but y is not equal to 3.
Good job. Number 4.
Write down the equation of h of x with h of x is equal to okay. Umbonise original.
Now it's gonna get libhale.
Nayi. So kuzoba 2 h of x is equal to 2 over kuzoba x plus 2, x plus 1 plus 2 plus 1 minus 4. Sekuzoba 2 over x plus 3 bese minus 3 h of x.
Abekhona yokugqibela apha. Use your graph, which is the last one. Use your graph to determine values of x for which 2 over x plus 1 is greater than or equal to negative 1. Use your graph to determine the values of x for which 2 over x plus 1 is greater than or equal to negative 1.
Yeah. Values of x. Mara graph angiyigcowanga se. Yo.
Hey, graph oyidluli.
Sa?
Kothi graph oyidrawanga. Oh, that's why. Kaloku mna bengicabanga ukuthi soyidrowile, so ede uyidrawa.
Eish.
Okay, so but you can see most that this 2 over x plus 1, if you take the negative 1 over, it's the function f of x, right?
Sa?
Most you can see that if you take the negative 1 over, this is the function f of x. You see?
Yes.
Yeah.
Oh, why?
So you only realize that more transpose or negative 1. Then you are left with 0 on this side. So this question is the same question that's like asking for which values of x is f, the function, greater than, meaning where is the function above the what? the x-axis? In other words, where is y positive for the function? And where is it on the x-axis for the function? Yeah, but okay, of course, you will know if you've sketched the function. You won't know if you haven't sketched. Yeah, because this one, you first transpose, then you see, oh, this is the function, the f of x most. So what's the values of x where this function is above the x-axis? Okay, and what is the value of x where the function is on the x-axis? Okay, so that's how you. No, it's fine. You like bengifuna nje ukutshela ke njengamuntu ongadwebanga. Otherwise, I think with that said, dark skinned, I think we can call it a night. Sure, but you need to rest as well so that it's override for a mini exercise.
Yes.
Yeah. No, it's fine. Because the interaction, it helps. At least it's more helpful for nabantu laba mamela. So siyabonga.
Okay, sorry guys.
Sure. So do you state it as a final answer or just a given condition? What happened there with Sekhamit? I am so wrong. What were you wrong about? Realize that f of x in this case is greater than and equal. Greater than and equal. Equal to minus 1. Oh, okay, I see where you, yeah. So this one, but at least you saw what it is, that how we got the answer in the last question. Sorry guys, I think I missed a lot of the things that you guys were commenting about in the comment section. Black Lady, question 4. Which question 4 are you talking about? Which question 4 is Lady talking about? Black Lady is saying I must do question 4. Where's question 4? What question 4? Question 4 on what, Black Lady? You're saying I must do question 4. Black Lady. Good eye on spotting. Black.
Sir, question 4 from the question that we're doing right now. Question number 4.
Question number 4 from the question I was doing right now. Question number 4 from the question I was doing.
Yes,
right
can you
now.
please explain how she got to the final answer?
Oh, okay.
Yes,
so
thank you.
Mostly, the first thing is that h of x is a new function, right? And how is it formed? It's formed when we do what to f of x? When we shift it 2 units to the left, firstly. And then when we move it down by 4 units. So you have to then obviously check this x plus 2. Where is it supposed to be substituted? It is supposed to be substituted where x is, right? So where x is, we need to write x plus 2. So if we write h of x, we are going to say h of x is equal to 2 over. For this x plus 2, we substitute x plus 2 in the place of x. So that means x plus 2, there's already a plus 1 there. Okay, so that's why she said add 2 to the 1 that is already there. Then, remember there's a minus 4. This minus 4 is a minus 4 that is having effect on the value of 2. So we say plus 1 minus 4. Then she got the answer 2 over x plus 2 plus 1 is 3. 1 minus 4 is negative 3. So that is the new function h of x. This is the
Thank you so
equation
much.
of h of x.
Thank you so much.
You're welcome, Blakely. All right, so why is this now? I'm a Juliet White. Oh man, why are you guys killing me in the comment section with oh man, you guys are killing me. Oh my goodness. Yo. Romeo and Colota. So we playing the Romeo and Colota. We're also playing the Romeo and Juliet. Oh my goodness, this is just, yeah. Guys are entertaining there in the comment section, that's for sure. All right, guys. I think I'm gonna call it a night. Actually, I think that's where I end. That's where I end. Black Lady, unless Black Lady has other questions or concerns. Do you?
No questions anymore.
No
Thank
questions,
you so
no
much.
concerns, no queries, no nothing.
No, I wanted to ask about the live. Like, how many times in a week?
Oh my goodness, Black Lady, if I had the answer to that question, I'm telling you, I would give it to you guys every single time. So the past few days it's been happening, you know.
Okay, what time do you start?
So I usually start at like 10, but the thing is I couldn't start at 10 today because I was held up by like the grade 8s in another live, grade 9s actually in another live that I was doing in another TikTok platform where I attend to grade 8s, 9s and 10s. So yeah, so I was planning, for instance, to start this live at 10, but it did not happen. I think I ended up starting at 2:11.
Okay.
Yeah. So at best, I usually want to ideally start at 10 with you guys so that I can at least push up until maybe latest 1, not 2 and stuff. But today I had to push up until this time because I started late. So,
okay,
yeah.
no problem. Thank you so much.
And are you in grade 11 or 12? Are you writing soon? Have you written?
I'm doing grade 12.
Oh, awesome. So when are you writing then? Like maths?
Friday.
Oh, you're writing paper 1 on Friday?
Yes.
Oh, nice. Oh, nice. How's the calculus treating you?
Very, very, very nice.
Nice.
Yes.
I'm very happy to hear that. Wow. Nice.
It's very nice, Jim.
I think some people have been having some serious calculus woes, you know?
Yeah.
Yeah, because like I've actually, so I think maybe, I think 3 nights ago, if not a little bit more than that, I started doing cubic functions for like your calculus because a lot of people were saying, hey, cubic functions, they're giving them the runaround. So I literally was doing, I think, 2 successive nights I did cubic functions. I started optimization, right? But then I got distracted again because, like, you know, time and what have you. So I started optimization. I did a live lesson. I did that live lesson and then I ended up uploading the live lesson onto my YouTube channel. But then I've never gotten back.
Oh.
I've not gotten back to the completion of the calculus because I did calculus of motion, right?
Okay.
But now I needed to do calculus of like your solids, basically, your 3D.
Oh, yeah.
Yeah, that calculus that involves volume, surface area, and
Okay, I see.
the likes. But yeah, hopefully
That's
I'll actually get that live done, because it's just at the time, like I said. And now grade 11s have been crying for my attention now, and then whilst I'm busy with that, like grade 11s want this, at 10s want that too. So it's just I
it's a
feel like
lot.
it's a lot. I want to get to everyone, but sometimes I just can't. And so I'm glad, Black Lady, that you actually are finding it. You're cruising with calculus, because that's sweet. That means
Yeah, Shema, with paper one, I'm good. The problem starts with paper two. Especially trigonometry. Oh,
hayibola, hayilethi, tricky.
I struggle with trigonometry, I don't wanna lie. I'm good with Euclidean and all that analytical and stuff.
But the
Trigonometry.
trick, but what aspect of the trick is giving you a runaround? Like which one? Is it the application of compound and double angles?
Everything with the graphs. Like, I can't even prove an identity. If you would give me like a question, prove this identity, I wouldn't. I would get 0.
Aye, Black Lady. Aye.
For real. Like, I
When are
have
you
trigonometry.
when are you guys when are you guys writing paper two?
Monday.
Oh, Kanene, you write Friday and then you write Monday.
Monday, yes.
Okay. Yeah, okay, maybe I need to factor that in the weekend then. The paper two.
I would be so glad.
The trig aspect of it though. Yeah, because
you-
I don't understand. Identities are sweet.
Like the whole trigonometry. Like,
I don't know. We'll do it. We will do it on the weekend.
okay, no problem. Thank you so much.
All right. Cheers. Bye.
Bye.
Oh, long night. Long night. My goodness. Okay. Yeah, guys, thank you so much. Romeo, thank you so much, buddy. I really appreciate seeing finally someone who enjoys calculus. So calculus is really a pain, for some people. Yeah, thank you, bro. Thank you, Romeo. I appreciate, my guy. Appreciate the love, the heart means the goodness. You and the Sekhamezi are literally my sugar daddies and mommies for today. So thank you so much. Thank you for the sugar. That's why I was saying to you guys, I was saying to Romeo there, also Tatu Kiesi, I think, yeah. Thank you so much. Much appreciated. Thank you. But let me ship out because what a night. I need to rest. And I'll see you guys tomorrow on the next segment of Matt's Game.